You know, this is not about new innovation. It's not about you know, something that's brand new to the industry. This is industry best practice. That's what this is all about. And it was taking an existing Tier 4 data center in full production, highly redundant, highly resilient facility, and looking at how we ran it. And you know, I was being tasked to reduce my energy consumption, reduce carbon footprint, and you know, just implement industry best practices. So again, this was a holistic approach from eBay's perspective in an existing Tier 4 data center, 140,000 square foot, roughly 80,000 square foot of raised floor. Through an 18-month, so through this 18-month process, we were able to achieve a reduction of 19% overall on our starting PUE. Some of the things that we implemented, similar to Facebook, is a blanking panel program, a floor tile management program, so understanding exactly where your floor tiles are positioned in your cold aisles, and if it's low versus high flow, and making sure that you have the right tiles in place to what you actually need to the 7-foot rack level. We also looked at both hot and cold aisle containment and what made sense for our current design. We also looked at some redundancy in our UPMs or UPS systems. So we are at a 2N+1, realized we had some excess capacity, potentially made a business decision, worked with our OEMs to come up with a modular rotation, which gave us some pretty good returns as well. We also looked at lowering our cooling tower set point from a typical 75 degrees in Phoenix to 65 year-round, and saw some really good returns on that, as well as lighting control. So we had over 700 T8 fixtures that we changed to T5s. In the blanking panel program, it's pretty simple. Guys, again, this is not rocket science. It's about going in, understanding you know, what you're doing on your raised floor, and ensuring that everything is blanked off. And what does that do? It you know, isolates the intakes and the exhaust on all of your systems at the rack level. It prevents obviously mixing of cold aisle and hot aisle streams, and ensures limited bypass airflow. Again, I touched on the floor tile management. It's important that you partner with your critical facilities team, that you do a baseline, understand what you're delivering to the rack level, understand that you, or ensure that you have exactly what type of tile based on need, again, at the 7-foot rack level. Areas that we couldn't contain or just didn't make sense for us to contain, we still had issues with best efficiency. I know probably several of you are facing similar problems with your Cisco switches, and how do you contain hot air if they just happen to fall into a hot aisle, and making those most efficient. So we used curtains to block off our hot aisles and contain that and away from those Cisco switches, and saw huge efficiency gains in operational excellence on those.
So Rich, if I can just interrupt and ask a quick question on that. Do you mean the Cisco switches that have the side airflow?
Yes, yes, absolutely. So we actually used thermal cameras to look at before and after, and if you take a thermal shot and you can see the way air flows from side to side, and you start at the first Cisco switch, and by the time you get to the other end, your temperatures increase just dramatically.
Mm-hmm.
So containment, we did similar to Facebook. We partnered with our original design electrical engineer and mechanical engineers and put together CFDs of the raised floor. We trended data on 3 different scenarios. We did a hot aisle containment, a cold aisle, and then a hybrid of both, and then trended that data over several weeks using wireless sensors. And again, based on our current raised floor design and on our data center design, I'm dealing with managing a T-pack concrete ceiling, 17-foot ceiling, so there is no common plenum. So I'm working with what I had. So this made the most sense for us. Cold aisle containment we found to be the most stable under the tests. Our rack inlet temperatures were more stable, and the crays, the crays were less sensitive to reductions in air supply quantity in those containment areas. We also looked at installing hoods or increasing the hoods on our cray units on the floors so that we could give the hot air plumes a better chance of getting to the crays themselves instead of mixing with cold air along the way or ambient temp. That obviously increased our delta T across our chill water coils, increased the efficiency of our chill water system overall. So again, some of the strategies and best practices that were implemented both from electrical and a mechanical perspective. I talked briefly on lowering the cooling tower set point, which we saw significant gains from. Lighting controls and replacing all of our T8s with T5s. We were able to implement, again, working with our OEMs, very important too, that you get a written process down with your OEMs, both from your UPM module manufacturer and your battery manufacturer. Get them in sync and understanding what you're trying to do and agree on paper to your process and take advantage of that. Again, that's a business decision to use capacity, excess capacity. So over the 18-month period, again, starting from day one back in January of 2009 until July of this year, we realized a 19% reduction in our PUE. And this is just to graphically show you how that trended. Kilowatt load, so IT load in the facility has increased over 50% over that 18-month time frame, with a total site load increase of 25%. And you can see the average total IT load in yellow versus the mechanical load, which is the solid green underneath, and then our building load on top. So mechanical load has continued to go down or stay steady at this point with IT load as IT load increased. So overall, the summary results, we realized a total 13% OpEx utility savings based on these efficiencies and implementation of those over the 18-month period. This is just a graph to show you a realized 16% savings in total utility power consumption. So the orange line being what our actual use was, the green line showing what it would be if we hadn't implemented these best practices, and then the blue line is the delta between the two. Carbon footprint reduction, again, we realized an actual 15% reduction on CO2 emissions and towards meeting our corporate goals as well.
That's it. That's great. Thank you so much, all of you, Richard, Jay, Brendra, and Dan. So let's go ahead and dive in a little bit to some discussion about this. These are both very interesting case studies. So maybe this is actually a question really to both Facebook and eBay. Is I noticed you mentioned about the energy savings, and you actually made your equipment more efficient. And partly this is really through increasing the delta T, right, the temperature differential between the supply and the return air intakes or water temperatures. In doing so, you not only saved energy, but you also regained back capacity of your cooling system. Isn't that true? Rich, would you like to talk about that, hit that first?
That's correct. It's not one for one, obviously, and we've had discussions at length with both our electrical engineer and mechanical engineer to understand what that capacity correlates to. So we gained back both from on our mechanical and electrical side, but then it's also understanding what is your pinch points along the way to increase then capacity potentially on the raised floor. And it's building a tool to understand from start to finish what those pinch points are, and then you address them as they come up.
So in some ways you can say, well, we not only saved energy, but we also saved capital expense, future capital expense, because you deferred some additional cooling capacity that you may not otherwise need to buy now.